Let's now move on to looking at our sample vulnerable app so that we can identify the sort of risks I'm talking about when I say leaky APIs and hidden APIs. And the first thing we're going to do is go back and start Fiddler. And of course, as you saw in the last module, we can learn an awful lot via Fiddler. As you also saw in the last module, Fiddler can capture a huge amount of data, including data you don't really want. So what I'm going to do is just jump over into my filters. I'm going to say use filters, and I'm going to change this host name from www.troyhunt.com to hackyourselffirst.troyhunt.com. That's what the mobile device hits for every one of the API requests. And again, that's a live running website. You can go and access this right now and see exactly the same services for yourself that you'll be seeing throughout the rest of this course. So that's great. Let's just move off this tab and it will save it. Just to show what I mean, back to the filters tab, the yellow box has disappeared. This filter is now active. Now what I want to do is go and fire up our sample vulnerable app. So I'm going to drag the emulator over here just to the right side of Fiddler so we can actually see the request that it makes as it loads. And now we can see the requests that the app has made. That's great. That's just the same as what we were seeing when I loaded apps on my iPhone and proxied the traffic through Fiddler. So once again, the Windows mobile app in the emulator here is reflective of the same sorts of apps you'll see on other devices. Let's take a look at this first request we see up here. If we go over to the inspectors, we'll see that it's a GET request to API/supercar/leaderboard, and it then has a query string. If we scroll over a little bit and look at the content type, we can see that it is JSON. So we can always go down and look at the response with the JSON syntax highlighter. So here we go. This is pretty predictable. There's the McLaren. There's the Nissan. There's a Pagani. Now, of course, one question you might ask in looking at this is, do we really need all of this data right now? Look at this compared to the app. I'll move it over here a little bit. In the app, we see the manufacturer, or the make, if you like. We see the model, so for example, P1, and we see the number of votes. Do we really need to have engine capacity, engine layout, speed and torque and power? In fact, we're paying a premium to return all of this data when clearly it's not even being used. At least not yet. There may be use cases where this data is then reused and it saves another action later on. So I don't want to rule it out completely. But following from the earlier module where we looked at really excessive image data, it's a point worth making. Now, of course, the other thing we see in the requests here is a bunch of images. So we can grab one of those, down to image views, and there's the McLaren P1. Next one, there's the Pagani Huayra. There's an Aston Martin 177. Now these are actually very small images too. 60 by 45 thumbnails. That's great. Efficient, makes sense, and as you can see from the body size up here, they're only about 1.5K. Let's get back to the security side of things though. I'm just going to scroll over so we can see the host and the URL. I'm going to bring back the emulator with the app, put it over to the right again. Let's now take a look at one of these vehicles. We'll just grab the first one. We'll drill down, and as we drill down we see two more requests. Now one of these, number 57, is clearly a request to an API. We can see that in the URL. So that's probably gone and gotten us the data that we see on the screen here. And the second one is a request to a JPEG. And that's obviously the car that you see in the image. So let's drill down and take a look at the response from this API. Now just before I do that, note carefully here the data about the votes. Lewis, Jensen, Troy. We've got a name. And then of course we have a comment on each of them. That's the only data the app is using on the screen at the moment. Let's have a look at what comes back from the response. We'll go into JSON mode. And now we can see something rather interesting. So first of all, we're seeing a whole bunch of data about the vehicle. That's to be expected. And we are actually showing this information on the screen too. But here's the interesting thing. Let's scroll down a bit and have a look at this collection of votes. Here's what's really interesting. The comment is fine. We've got that on the screen. But we've actually got the email address of the person who voted. Not only that, but we've even got the password. There's Lewis's, there's Jensen's, and if we go down a little bit, here's Mark's, and you can see he's got a null comment, which is why it wasn't actually showed on the screen, and here's mine. Why on earth do we have passwords returned by the API? Who would do this? Well, there's actually a very good explanation for why this happens. It shouldn't happen, but there's a good explanation. And it's simply this. Many modern frameworks make it very easy to persist entities between tiers in an application. So what I mean by that is an underlying entity in the database, such as a user, can easily have the same model definition, so the name of the table, the columns, persisted through to the application tier. It might persist through to an object-oriented entity with attributes. That entity then often persists through to the interface layer. In fact, back in the Hack Yourself First course, I gave a demonstration of what we call a mass assignment risk. And that exploited the same underlying vulnerability, where the model was persisted through all the layers, and we were actually able to elevate privileges by making the person an administrator simply because the isAdmin flag was assignable directly via the website, even though it wasn't actually displayed. The same sort of thing is happening here. We've got an entity in the system that has the comment and the email and the first name and the last name, and also has the password. And that entity is simply being automatically persisted via the API. Now clearly, this is a terrible practice. But again, I want to reiterate, it happens. I've seen it happen in real live applications. You may well find that if you proxy the traffic on your device and start opening apps, you'll see similar behavior. It wouldn't surprise me in the least. I did actually see this in a real-world application recently. And in this particular app, it was possible to get a list of users of the system. And that's fine, there was a legitimate use case for this app to do that. But along with the non-sensitive data intended to be shown in the app, the API underneath was doing just this. It was returning passwords. Now it only took me a couple of minutes to discover that, because the first thing I did was proxy the traffic through Fiddler, which of course, as you've now seen, is extremely trivial. After I discovered this, I spoke to the developers and said, guys, what's going on here? I just proxied this traffic through Fiddler and look what I found. And you know what the developer said to me? He said, it's okay, our users don't use Fiddler. That might sound a bit ludicrous, but it happens. So don't think of this as a hypothetical. Scary but true. Let's move on and take a look at properly securing this API.